let's start from the hardware, okay? So usually you have a rack, you have three x86 servers. We'll talk later about the models we suggest. And you have 4 fabric switches, plus a classic legacy management layer 2 switch. And we'll see how all these are connected. So few suggestions. Maybe I don't even have to mention this, but proxy servers, enterprise proxy servers are evil because we download a bunch of software from internet, and if you put in front of everything a proxy server, nothing, I guarantee, will work. And then stay with the suggested hardware. So here you have many choices. This is the hardware we use and we suggest you to use for different reasons. The first one is that we work with it every day. So if something goes wrong in your deployment, we will be able to reproduce exactly the issue and work with you on the mailing list, and we will be able to understand each other better. Say that the hardware, again, should be just an x86 server, nothing more. The very important thing is that you use that 40 gig network card, which is the one we use, because during the deployment, we grep in the system for a special driver that just that card has. If you don't use that card, it's not a big deal, but we will need to do some modifications in the code. And then, of course, another point, the Acton switches, also those are a possible alternative. So right now, we support basically all the switches that have a Broadcom Trident 2 chipset. Again, if you use a different model from that one of the switch, you have to contact us or find a place in the code where to do some customization. Are just 2 or 3 places, nothing more. Okay. So let's talk about software. As you know, unfortunately, our system works still with Ubuntu 14.04. It's not great, but it is what it is. It's in our, it's in the plan to update it to 16.04, but it got, of course, deprioritized. We will work on it. So the only exception I suggest you as the dev node, the developer machine, the one you use to push the code to the head node, to use 16.04 for different reasons, especially for automation. And you'll understand better why later on. So on the head node, basically you don't need anything except 14.04, and you have to create a user. Can be called whatever you want, as long as the user on the dev node can SSH into the head node and can be a sudo run that machine without having to input the password. On the dev node, we have a bootstrap script that you will find on our guide online that basically set up your machine with specific versions of Ansible, libvirt, vagrant, and other vagrant plugins. If you want, you can do this manually. It's not a big deal. You just go through. It's a very simple SSH script, a bash script. So that's it. Compute nodes and switches, you don't even have to install the operating system because we will take care of it using mass, and you'll understand in a second how. So let's start to see how these things are connected together. So I'm going to show to you the same elements I showed in the previous slide, but now they start to be connected together, and we will start with the data plane, which actually is the one you see represented in most of our slides, and I think is the most straight one to understand. So this is the fabric. This is a classic fabric closed topology, right? So the 2 spines, 2 leaves connected together, in our case with 40 gig cables, fiber cables. And then, of course, you have the computes attached to the fabric, always with 40 gig cables. So here is where your Intel cards are, and they connected through those cards to the fabric. Of course, on the left, attached to the fabric, you have the access devices. And on the right, you have the connection to the upstream network, so to the Metro network. All clear till here? Yes? No? I take it as a yes. OK. And of course, when the idea is that a user connects through an access device, let's say an ONU, an OLT, it hits the fabric. It can go through some of the compute nodes depending on the services that the user needs to go through. And then finally, in case, goes to the Metro network. Okay, another view. Let's put together what we said till now. So these are the same connections I showed you before, okay, the red ones. Let's add one more piece, which is the more complicated to understand, which is the control plane. Okay, so I showed you before one switch. One switch that in practice should be either partitioned with a VLAN, okay, or you should have two switches, okay? So these, consider it as the first half of the management switch I show you in the first slide at the top of the rack. Let's call this the green network is the external network. So external network because this is the network that allows your pod to reach internet, okay? Okay, so indeed we have an internet connection. This is likely where you will connect as an operator. And as you can see, the only node in the pod, this is a very key, important concept that connects to the external network, is the head node. No other node has connections to internet. And then we have another network. Again, this can be either another management switch, okay, used for what we call internal network, or it can be just a partition with a VLAN on the same management switch. So here is where another interface of the head node connects. So the head node, first thing to remember, has two interfaces, one connected to the outside, one connected to the internal network, where the compute node connects and where all your switches connect. As you can see, the compute node have two connections that go to the internal network, a management classical Ethernet connection and the IPMI connection. So why do we need the IPMI connection? Because we use MAS. Now, I have at least a person that I count here that use or work for Canonical, so I hope I'm not saying anything bad and I'm not making things too simple. But essentially, MAS, how many of you use MAS already? Do you know what MAS is, roughly? Yeah, 1, 2, okay. So maybe I'm making it really simple, but I see it like an evolution of a Pixie server, okay? So MAS, basically, it's a server. You use it to manage, when you have big data center, you use it to provision a bunch of compute nodes in the network. So you have a server, you want to install Ubuntu on it, you boot the server from the network, MAS is able to provision the software on it, okay? It installs Ubuntu or other operating system, that's it. It runs basically a DHCP server, a DNS server, a TFTP server to let you download the images. But the key concept that I want you to understand now is that MAS uses two interfaces to communicate with the client, okay? Again, an Ethernet management interface and the IPMI interface. The IPMI interface simply is used to reboot the node, boot the node, shut down the node from MAS, okay? So coming back to these slides, these nodes, I told you before, they don't need the operating system installed on them, okay? And the reason is that we run MAS on this node, on the head node, and it's used to install the operating system on this guy, and all the fabric switches for you automatically. So another view again of the same thing, this time simplified, hopefully. So again, we have our head node, the green network, which is the one able to go to internet and connect the operator to the pod. And then we have the blue network, the internal network, okay? So as I said, the head node runs a bunch of stuff. It runs including OpenStack, including ONOS, including XOS, including MAS. Why I'm insisting on this MAS thing? I'll tell you in a second. It's a very important concept to understand for your network requirements when you deploy a pod. So in the meantime, how things works. Basically, you download on the dev machine when you want to install ONOS, you download the code repository, okay? Then you basically create a VM that packages all the software that you need to deploy code. And then we start to fetch, always here, a bunch of packages, images. We build Docker images, as Zach told you before. And then you take all the software and you push it to the head node. Once the software is installed and deployed on the head node, you have only one thing to do. You go physically here, and you start to press the button to reset, to reboot all these devices. These devices reboot, and they get automatically installed and provisioned by the head node. Okay? Of course, you could argue that it doesn't make really sense to do all this mess for 3 nodes. Of course, as you may understand, this applies to huge data centers where you have a bunch of compute nodes. So the only thing you would have to do is to go there, attach a cable, reboot your node, and the node gets installed, and it works. Okay? Let's go back for a second to mass, and let's understand why I was underlying so much this thing. So let's talk about the broadcast domains that we have here. Okay? So the head node, as we said, is the only node with 2 network interfaces, one connected to the external network, one to the internal network. So here you really have 2 networks, 2 broadcast domains, okay? The first one on the left, it has routable IP addresses. Doesn't mean that they have to be public, but they are routable, right? You have to be able to reach them from outside. It has access to internet, and the addresses are given by you, by the administrator of the network. On the right, we have the second broadcast domain, where you have the addresses. The broadcast domain is just here. So if from the rest of your network you try to ping these addresses, to reach these addresses, you won't be able to do that, right? You won't be able to ping them. So you can have accesses to those nodes only from the head node. They don't have access to internet, those computers, not direct access to internet at least, if not through the head node. And the addresses are not given by the administrator. The administrator, of course, can configure mass to give a certain set of addresses, but the addresses are given out through the HCP from the head node. Is this clear? Because this is really a key point when you deploy Cord. It's very, very important. And is what, when we go and we do deployments, there's always a trouble here because people don't understand and start to say, oh, but this is my address, this can go to internet, cannot go. So I want that you have fixed in mind this point. Yeah? Okay. Okay, this is great. This is basically about it. Really, you don't need anything more to deploy Cord. It's like, the good news is that is 3 commands. If you cable things correctly, it's nothing more than that. Now, the pain point is that, as you understood, Cord is a big beast, right? There are lots of pieces that needs to come together. We have to download and build lots of stuff. And so here is where people start to have problems. This is actually not really updated. It refers to 3.0. Now we do really much better, but still, it takes 1-2 hours at least, if things go really well, of human interaction before you are able to deploy a Cord pod. And then people, typically operators, start to tell me, okay, but I want to try something and then I mess up something else while I was doing that. Now what do I do? Should I lose other 3-4 hours to deploy again a Cord pod? That doesn't really make sense, right? What if I want to test a fresh installation with the changes of last night? And this happens. It's a very common use case. Code change every day. So that's where our automation system and the Jenkins plugins that we have come in. Okay. So let's take again the network that we saw before, and let's try to add 2 more components and make it a little bit more complicated. And we will talk again in a second about the broadcast domain we talked about a couple of seconds ago. So we have 2 more components here. One you had clear in mind is Jenkins. You guys know what Jenkins is? Yes? Yes. So for who doesn't know it, let's make it simple, okay? It can, for this purpose, instead of running a script manually, you can put it in Jenkins and press a button, and Jenkins runs it for you. If you want, you can schedule it. If not, you can call it whenever you want. That's pretty much it in this case. And then our best friend, mass, comes back also here, okay? So why do we added another mass? Because you remember we had another mass already running on the head node. Why do we have to have another one again? So the simple reason is that every time the idea behind these scripts was to replicate every time an entire installation of a pod. Completely automated installation. So, for example, I couldn't really say that the installation was completely tested if I was starting with a dirty operating system. So the very first thing, and you will see it in a second, the very first thing we do with our scripts is to use mass, this mass, to wipe out the content of the head node every time, reinstall a new copy of Ubuntu on the head node, and then from there we run all the Jenkins scripts. Then we go there, and automatically we reboot all these nodes. Just the commands that I described to you a few seconds ago, but we do them automatically, okay? So now, remember, broadcast domains, okay? So here is where the line was before, right? In the middle of the head node. And if you remember, I told you the head node is the mass server, and these are the clients, okay? This is one broadcast domain, this is another broadcast domain. So we saw this picture before. Here is mass giving out IP addresses to the clients, to this side of the network. Now we add one more piece. We have one more mass server that is our other DHCP server that is giving out IP addresses to the head node on this interface. Does it make sense what I'm saying? Yes. Okay, so every time, again, we use Jenkins, we use the API of mass, we say reboot the head node, reinstall Ubuntu on the head node gets an own IP from mass through the DHCP. At this point, I'm able from my Jenkins machine to reach the head node and run commands on it. I run commands on it. I have also a developer VM, okay, connected to the same network. I download the core software, I build the core software. At this point, again, the head node is reachable, is brand new. I push the core software to the head node, I deploy it. Once it's deployed, I go on the compute nodes and on the fabric switches, I reboot all of them, and they get the new image from the head node itself. Okay, so let's go back where we were before. And let's see how much I can confuse you now. So it's pretty much the same network view I was showing you before. But if you remember, the IPMI connections were on this side. Now, when you do automation, I usually ask people to move the IPMI connections on the left side, on the external network. The simple reason is that from my Jenkins machine that you saw before, I have to be able to reboot the compute nodes. I told you 1 second ago, right? I said a human usually go there and press the button of the compute nodes. But now it's the script that has to do it, okay? And then you can argue, well, but now the head node is not anymore able, the mass on the head node is not anymore able to use those IPMI connections to work with the compute nodes. It's not true, because if you remember, we said the head node is the only guy that has connections both on the external network and on the internal network. So to the head node, it really doesn't matter. It can reach anyway the IPMI of the compute nodes through this network instead of going on this side. Okay? I see some faces really lost now. But I told you, we were going to, it's easy really, but that's why I wanted to stress the concept of the two broadcast domains. Okay, so all the Jenkins scripts I talk about are all public, and I'll point you in a second to the right location to find them. So one choice that you have is to just go and build your Jenkins machine, create your jobs, and just copy and paste basically our scripts and customize them as you want. The thing that sucks about this is that if we update, we have a team, a QA team that will talk also about this tomorrow, that is constantly working and improving the scripts. Now, you have a choice. Either you go your way and periodically you copy and paste the new scripts and you get the improvements, or to all our partners and collaborators, we offer what we call Jenkins as a service, right? Consider it like a reset tool. We sponsor it also like that. So basically, all what you need is to connect your company through an IPsec VPN to ONLab, to ONF. And then ONF is connected with another IPsec VPN to Jenkins. So the final result of this is that basically you have in-house our Jenkins server, which lives instead in the cloud. But it's like having it there, okay? So the good news is that we prepare the scripts for you. You work with me likely or with the QA team. We prepare the deployment together, and you get in a few days ready to go, a reset tool to be used on your pod when you want. Okay, we already went through this, so I don't really think, I know repetition, helps. By the way, all this documentation will be online. So essentially, again, let's go through it again one more time. What Jenkins does, we reinstall Ubuntu on the head node using the mass APIs. We download the latest source code on the dev machine, which is in your pod. Your pod, by the way, at this point looks like this, right? Because your dev machine, remember, before it was your laptop. It's the operator laptop, likely, lots of times. This time, since it needs to stay in the pod all the time, it must be an additional server, okay? So with Jenkins, we download the latest code on that machine. We download the pod configuration, and you'll see some examples in a few seconds, basically a configuration that describes your pod. We deploy, and we reboot the compute nodes and the switches, nothing more. And then you have a pod ready to go. Okay, brief overview of the Jenkins scripts. I really don't want to go line by line, but at least I want to give you a taste of how they look like. So first of all, if you want to find them, you just have to clone the cord repository, okay? So when you download the cord repository, you will find the directory OpenCord in your root directory. If you go under build, you have a file called jenkinsfile.newbuildsystem. You know that in 4.0, the build system just changed. And so that's the file that uses the new build system. You might know that as I was saying before, to deploy cord, each pod needs to have a specific pod configuration, okay? And for this configuration, since there's no human saving and downloading the configuration every time, what we do is that we have a separate repo, which can be also your repository, where the configuration lives. So every time during the deployment, we download this file. And then for those of you working with Jenkins, you know that Jenkins is a pain. You have to insert, for a job like this, you would have to insert like 30 parameters in the job. It doesn't scale, it doesn't work well, it's horrible, it's not well maintainable. So to avoid this, we created a third repository where all the deployment parameters are for each deployment. You'll get an idea now concretely of where they are. So what I want to tell you with this slide is that all this is public. It's completely open. You can see the examples, you can play with it. It's quite easy once you read the script. And it's just 3 pieces of software. Okay, let's have a look at them. So, wait, let me move it a little bit this way. Again, I don't want to go in the code. So, well, maybe, of course, I took a great job that always passes. We have also jobs that go worse than this, and are all public online. And that's exactly one of the goals of having a job, right? Because we know, for example, when master fails, which is great. That's not the fact that it fails, but the fact that we know it immediately. Anyway, this is how a job looks from outside. For example, let's assume you run your pod here. You want to build your pod with our system. You will see when you start the job, and we can do it online now immediately, we do what I told you before. We parse a deployment configuration file, which describes the deployment. We essentially check out the cord repository. We redeploy Ubuntu on the head node. We download the pod configuration. We generate the configuration for the pod. We reserve some specific IP addresses for the fabric switches. We deploy, and then we basically power cycle the compute nodes, and we reboot the switches. Basically, that's it. I skipped some technical detailed steps, which are not relevant right now, but that's about it, right? I'm not sure I'm still logged in. By the way, this is the pod. Since we are in QCT, we should say this. If you have seen the server room outside here, there's a glass server room, and there's a pod that you can see. So here in QCT, we do exactly this. We have 4 pods dedicated to us. The first of those pods, you can see is named like that. You can see it online on jenkinsopencore.org, is the pod that we use to build every night our software and run the main tests. Okay, and you can see it live there and live on Jenkins. So hopefully, this won't give me too many errors, starting from the fact that I have to log in again. Be patient, just a second. I want to just show you how it works. But basically, once you go inside, you just say build with parameters. You click build. You can go and grab a coffee or do something else. It will take about an hour or so, and your pod will be deployed and ready to be used, or ready to run tests, right? Of course, here the internet connection is not really assisting me, but you can either trust me for now, or you can come later. I think I'm just went on the wrong SSID now, but you click build and you'll see the progression starting, the job starting, okay? So let me find my mouse again, and let's move to the next thing. Okay, so let's go one more level deeper. I'm not sure everyone in the room can see this, and I'm not sure if I can, yes, at least I can make it bigger. Okay, so this is the Jenkins file, and it's 270 lines, which is not really terrible for building an entire pod, if you think about it. So I don't want to go through it again, completely line by line, but at least I want to give you some basics to look at it, because it's very easy. These are basically bash commands, nothing more, okay? So we parse the deployment. These are the steps that you saw before in Jenkins. We parse the deployment configuration file. We redeploy the head node. As you can see, we use the mass CLI and APIs to do that. We release the machine for you, who of you is confident with mass. We just run the deploy command again. We wait for the machine to come up, and if it doesn't come up in 30 minutes, we say it failed. We download the pod configuration. So, for example, this one, see, it's pretty immediate if you download the script, now that you know where it is, to understand all these commands. This is just a cd pod config, git clone, this branch, and that address. It's not rocket science, really. It's pretty simple. And these are the standard commands that you would run in a classical manual deployment, right? So you do make config, you do make build. Here is where I use the IPMI tool, a command line, just to reboot the compute nodes, nothing more, okay? How much time do I have, David?
7 more minutes.
7 more minutes? Okay. Okay, let's do one more thing. Instead of showing you pod configuration files that maybe you already know, do you guys have any question before we move forward? I want to make a good use of our time. Any question, anything that is not clear? All clear? Tomorrow we will have core deployed all around the world? Yes? Okay. Okay. This is a typical pod config file. Again, I really don't want to go through this because there are instructions online. But basically, this is, I told you before, we have a separate repository where we commit all our pod configuration file. When we have to do a deployment, we just download the corresponding pod configuration file. This, for example, describes a pod at ON Lab, at our office, okay? And it says deploy core, deploy our core, give these IP addresses to everything. That's pretty much about it. But if you go on the core guide, this is really a standard thing. So it's what you would use for a manual deployment. This is the other file instead that is specifically used for automated deployment. Again, it's always in YAML format. It's pretty clear, I think. It says where the pod configuration file lives. It says what's the address of the external mass server that is used to redeploy the head node with the API key and the reference to the head node. It says what's the username on the dev node. It says what's the address of the head node and what's the IPMI address of the compute nodes and of the fabric switches. That's it. These would be all parameters that we would put in Jenkins, but instead of putting them in Jenkins, we just put them in a more structured way in a YAML file. Okay? Okay, so let me, if I find the mouse, let me go back to this presentation. Yes. So, to conclude, I know I've talked about this for an hour, and it seems complicated, but trust me, the good news is that deploy core nowadays, especially, is not that complicated once you understand those couple of basic principles. It really takes, there's not so much software required. It takes a couple of commands plus the boots of the compute nodes, and we do the rest of the work for you. Automation, people really love it. It's your best friend. If you have ever installed Cord, I'm sure every one of you is looking forward to having a tool like this, where you can just click and say, okay, do it for me. There's not really a good reason why a human should do something when the software does it for you. Okay. It's useful for continuous integration, so you can deploy, configure, test, and then reset your pod again, or continuous development, where you want to try the latest code, you want to develop your latest code, and test it on the fly. It's very interesting, I think, what we offer to our partners and collaborators, the deployment on demand, right? It's offered for free to all partners and collaborators of ONF. We take care of the setup for you, and you just need a VPN to us, or any other way to expose at least your dev machine to ONF, to our Jenkins machine. I left you some references. I know we are stressing this in every talk. I'll do it one more time. Before, the documentation was on wiki.opencore.org. For the new releases of Cord, from the 4.0, the documentation is on guide.opencore.org. Okay? So please go and check that documentation, please. We did a tremendous amount of work to make a better documentation for you. So please make sure you check it out. There's a mailing list and a Slack channel. I had someone from the audience here that reported before that they had some troubles to reach to have support from China. I know there are lots of difficulties. We are working on it. As a first thing, I promise that at least these two work from China. So if the mailing list is open. If you write, is a Google group, I know Google doesn't work there, but if you write directly to this email address, it works. It's proven, it works. You don't have to register to that, okay? And the Slack channel, we were all in Beijing in August, and Slack works perfectly. So this, I think, is a good news for all of you. Of course, if you have any question, please let me know now, or just send me an email, and I'll be happy to answer all your questions. Thank you. Actually, I think we don't have any more time for questions. So if you have questions, send me the email or reach me later. Any question, guys? I'm sorry?
I don't have experience with keyboard. I'm just curious, like, what are the failures?
The biggest failure? Well, yeah, there's still some work to do, for sure. But I think it's improving tremendously with the 4.0 release. So most of the failures I see, there are lots of failures that could happen because your pod is not able to correctly download software from internet, and you just repeat the installation, and unfortunately the result changed because the repository gets up again. It might be that from the previous iteration you didn't clean up your system correctly, and so it's not really in a good state again. The automation really solves that, right? Because every time we make sure again that we completely wipe out and reset all the system, so we have a very consistent result. If you do it manually, we're humans, we forget things and we do things differently, and so the system gets compromised and you have different results. Right. Thank you. Oh, yeah, one more question. Okay, so I repeat the question for you. By the way, I should have done it also for the first question, but I think you got it. It was what are the most common issues that I find during deployments, right? So this question instead was on the network interface. So I suggested at the beginning of the presentation to use a very specific network card, 40 gig network cards. Actually, we have a bunch of deployments that use, including the one that you will see here at QCT, that use the 10 gig fabric. So again, it's not really mandatory, right? If you want to deploy at the current stage Cord out of the box, so without modifying any script, and you want to have anything going perfectly first time, you really have to use that specific card, 40 gig, and the fabric we give you. It's a matter really of changing the configuration in a couple of places otherwise. It's not a big deal. You just have to say, include this name of interface in the configuration. But you can use 1 gig network card, 10 gig network card. There are people that use the fabric switch 40 gig and the compute nodes with a 10 gig network card with the breakout cable. It can work, even with automated deployments. Okay, thank you again, guys.